So this is class notes B in lesson 2, and we are asked to solve this ODE. So again, let's try to classify it real quick to make sure we know what solution technique to use. So highest order of the derivative is 1, y prime, so this is a first order ODE. Asking ourselves whether it's linear or not, well, we'd have to put this in standard form. So to do that, we could multiply some things out here. So I could say this is 1 plus t times 1 plus 1 plus t times y, and then we could subtract over this y term, leaving this ODE. So actually in this form we see that this is our A of t, this is our B of t. I'm referring here to definition 1.1.1 in the lesson 1 notes. So in fact, this is a linear ODE. So we could solve this using the methods that we talked about in lesson 1. And because it's a non-homogeneous linear ODE, we would find an integrating factor and that would all work out. So the reason I said all of this to begin with is that there are some ODEs, and this is a great example, that can be solved using more than one method because they fit into more than one type of ODE. So this ODE we've just determined is in fact a linear ODE. Let's talk about how it's also a separable ODE though. And that's how I'm going to solve it in this lesson, since we've already done lots of examples of solving linear ODEs in lesson 1. So how do I know that this is a separable ODE? Well, so again, using the shortcut method that we talked about in the previous video, we are going to try to put all of the y's on one side and leave all of the t's on the other. And if we are successful, it is separable. And indeed, you can see that this only involves y's, this only involves t's, so separable. So that helps out a lot in terms of being able to solve it, because now we just integrate both sides. And hopefully we can do the integrals and we will have finished the problem. So on the left-hand side, I am integrating 1 over 1 plus y dy. On the right-hand side, I'll just do the integral. Integral of 1 is t. Integral of t is t squared over 2, and then here's my plus c. And then on the left-hand side, integral of 1 over 1 plus y, I'm going to say this is ln of 1 plus y. This is indeed a quick u substitution. So what I would do over here if I were to fill in the details is I would say, oh, u is 1 plus y, du is dy. So integral of 1 over 1 plus y dy is integral of 1 over u du, which is ln of the absolute value of u, again skipping the plus c's, and putting back in the u gets us to where we are here. Great, so that is the left-hand side, and this is the right-hand side. And now to solve for y, we exponentiate e to the t plus t squared, 2 plus c, and use our fact that we've been calling e to the c k to simplify this a little bit more. Great. And then solving for y, all we do is we subtract 1 here. So k e to the t squared over 2 minus 1. And that is our solution for this separable ODE. And that's the end of this class notes.